let n be the least positive integer such that 168 is a factor of 1134n. That is 168 completely divides 1134 to the power n. And it is also given that if m is the least positive integer such that 1134 to the power n is a factor of 168 to the power n. That is 168 to the power m is completely divisible by 1134 to the power n. This is the condition given, and what has been asked, the value of m plus n is questioned here. So I am going to prime factorize the given numbers. So this can be written as 2 into 3 power 4 into 7 the whole power n, divide by 2 to the power 3 into 3 into 7. So for the numerator to get cancelled, to be exactly divisible by the denominator, the minimum power of 3 should be 3. Yes, it is satisfying because we have power of 4 for 3, and similarly it should have at least a 7. So numerator also has a 7. But whereas 2, the minimum power of 2 should be 3 for this 168 to divide 1134 to the power n. So what I should have here, the least power of n should be 3 here. Similarly, this can be written as 2 power 3 into 3 into 7 the whole power m, divide by 1134 the whole power 3, because we have found out that the value of n is equal to 3. The least power of n is 3. And prime factorizing the denominator as well. So this can be written as 2 into 3 power 4 into 7 power the whole power 3. So this can be further written as 2 7 to the power m, divide by 2 to the power 3 into 3 to the power 12 to 7 to the power 3. So again applying the same rule. So the minimum power of 2 should be 3. Here it is satisfying. But here the minimum power of 3 should be 12, and the minimum power of 7 should be 3. So for these to get satisfied, the minimum power of m should be 12. So that if I put a 12 here, so the power is satisfying for 7 as well. So the minimum value of m should be 12. So what has been ideally asked here, at the end we have to calculate the value of m plus n. So m is 12 and n is 3. The least power of m and n will be 12 and 3, and sum of the numbers will be 15. So answer for this question is 15, which is option C.